Question 8, Part D, Part 1. Show that for all values of m, the line y equals mx minus 3m squared touches the parabola x squared equals 12y. The line y equals mx minus 3m squared touches the parabola or is tangent to the parabola x squared equals 12y if there is exactly one solution to the simultaneous equations y equals mx minus 3m squared and x squared equals 12y. So using the substitution method from equation number 2, we have x squared equals 12 times mx minus 3m squared. So I've substituted mx minus 3m squared from equation 1 for y in equation 2. So expanding the brackets on the right hand side, we get x squared equals 12mx minus 36m squared. Moving the terms on the right hand side over to the left hand side, we can form a monic quadratic equation, x squared minus 12mx plus 36m squared equals 0. So we'll call this equation number 3. Now there's exactly one solution to this quadratic equation if the discriminant b squared minus 4ac equals 0. So from equation number 3, b squared minus 4ac, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant term, we get negative 12m in brackets squared minus 4 times 1 times 36m squared, which equals 144m squared minus 144m squared, which equals 0. Therefore, the line y equals mx minus 3m squared touches the parabola x squared equals 12y for all values of m. Part 2. Find the values of m for which this line passes through the point 5, 2. Substitute x equals 5 and y equals 2 into the equation of the line y equals mx minus 3m squared and solve for m. So 2 equals 5 times m minus 3m squared. Moving the terms on the right hand side over to the left hand side to form a non-monic quadratic equation, we get 3m squared minus 5m plus 2 equals 0. Now the left hand side factorizes to 3m minus 2 in brackets times m minus 1 in brackets, and that equals 0. So from the left hand side, we get the solutions m equals 2 over 3 or m equals 1. Part 3. Hence determine the equations of the two tangents to the parabola x squared equals 12y from the point 5, 2. The two tangents to the parabola pass through the same point, 5, 2, but have different gradients, 2 over 3 and 1, which we found in part 2. Let's consider each case separately. So given point 5, 2 and gradient m equals 2 over 3, using the point gradient formula, we get y minus 2 equals 2 over 3 times x minus 5 in brackets. Multiplying the left hand side by the denominator 3, we get 3y minus 6 is equal to 2 times x minus 5 in brackets. Expanding the brackets on the right hand side, we get 3y minus 6 equals 2x minus 10. And then grouping all terms over to one side, so we have 0 on the other. In other words, expressing this equation in general form, we get 2x minus 3y minus 4 equals 0. Let's consider the second case. Given point 5, 2 and gradient m equals 1, again using the point gradient formula, we have y minus 2 equals 1 times x minus 5 in brackets, which gives us y minus 2 equals x minus 5. Rearranging this equation so that it's in general form, we get x minus y minus 3 equals 0. Therefore, the equations of the two tangents are 2x minus 3y minus 4 equals 0 and x minus y minus 3 equals 0.